Hello, and welcome to the newest series from Siemens Digital Industry Software, the Battery Podcast. I'm Nick Fidberg, and I'm going to be your host and moderator for today's session. But I'm joined by two guests. The first is Marc, the head of strategy and communication for battery. He also started the foundational work for the battery business in 2015 with others, and has led machine builder and end customer projects in the battery market since. Puneet Sinha is the Senior Director of Battery Industry for Siemens Digital Industry Software. He heads DI software strategy and cross-functional growth, focusing on batteries. He has 15 years of industrial experience in battery product and business development, working at auto OEMs, battery suppliers, and technology solution providers. Since we're going to be talking about the battery industry and the world of batteries in general, it might be important to define what we mean by those. So, Puneet, what do you mean by battery industry, and what do you want to cover with this series as we bring in more voices to the discussion?
Thanks for having us, Nick. For the battery industry, we are looking at the whole ecosystem, from lithium mining and processing to material and chemistry development to cell and pack manufacturing, and the integration of these batteries in a system, be it an electric car, electric aircraft, residential or grid-level energy storage, as well as recycling. It is very important to look at this whole ecosystem because there are strong dependencies, technology-wise, as well as the evolution of business across all these players. The way we look at it, the days when the cell suppliers are focusing just on producing cells, whereas end customers are focused only on taking battery packs, integrating in their systems, are gone. Increasingly, companies are evolving in their business value. Cell suppliers are increasingly looking to offer complete pack solutions. A lot of automotive OEMs, as well as OEMs in other industries, such as aerospace or energy storage, are heavily looking to morph themselves into battery business. That means they are investing heavily in cell development and manufacturing. And also, a lot of cell suppliers are investing in new chemistries. So it is very important to look at the whole ecosystem for battery and understand the dynamics across all these players. We want to talk to this whole ecosystem to understand and voice their challenges, the evolution of dynamics across this ecosystem, and how we all can work together to address the problem the industry is facing today.
So even as kind of a layperson, one of the buzzwords that I've been hearing around battery industry is Gigafactory. For those that may not know, can you explain what that is and why it's important for the future?
Puneet has mentioned a lot of applications that are around all of us, and all will be fed with batteries. So it means we don't need just one battery, we need thousands, millions of batteries. This Reading Gigafactory was founded nearly 7 years ago, and it means that a lot of companies have pretty good ideas how to produce one battery. They develop recipes, for example, to produce these batteries, but in a smaller range. And if it comes to a scale-up factory, we have 20 million battery cells, which is nearly 10 gigawatt hours, for example. You need more space, you need more factory sites, and you need, definitely more material. The machines have to be positioned in the factory, and if you have a lot of machines, like in a gigafactory, there is not only one stacking unit, there's not only one coating unit. There are in some cases more than 50 of these machines. And the size of this battery gigafactory, 1 gigawatt hour, will assume 10,000 square meter space. If you need 40 gigawatt hours, you can calculate you need then 40 multiplied with 10,000 square meter. This is a lot of space, and this is not done in your neighborhood. Mm-hmm. So it means these 20 million cells a day, for example, will feed 200,000 e-cars. And that production capacity is necessary to fulfill this demand, which will come up until 2030. So at the end of this decade, by around 3.6 terawatt hour production capacity. And that is the size of these Gigafactory. They are absolutely necessary to fulfill this demand, that we can use it for e-mobility, energy storage, and all other applications worldwide.
That scale sounds massive. What are the challenges that these companies are tackling to get there?
So these challenges, Nick, are evolving very fast. If you would ask me this question 14, 15 years back when I started working with batteries, that time we were staring at $1,000 per kilowatt hour kind of cost for battery. So making a 200, 300 mile EV was almost out of question because the battery cost would have been more than the full vehicle cost in some ways. But in last 10, 15 years, the battery industry has really made huge strides. The cost of battery has come down almost 90%, whereas because of all the improvements in the chemistries and the design, the energy density of the battery has gone up almost 3x in the same time. So these are some great progress that the whole ecosystem has made, but challenges remain. Some of the key challenges are the energy density of the battery. How many watt hour you can put within a kg, how many watt hour you can put it within a liter of volume. Those still need to be improved, while making sure that the battery, as these new chemistry come, the battery remains safe, it remains durable in the real world operation. So that continues to be a challenge, and companies are investing in new chemistries, new cell design, new pack designs. That continues to be a challenge. A much bigger challenge that has raised its head in last 7 years, let's say, is how companies can go and make these batteries or produce these batteries at scale cost effectively. As Marc mentioned, this Gigafactory, which is how you produce these cells at a giga scale. When you go from a small scale production to this giga scale production, a lot of new challenges start coming. The very first being how you set up these factories fast. Sometimes we are seeing these factories are taking 4 to 5 years to come into being. That is too long a time for a large scale factory to come into play when the technology is moving this fast. Other thing we are also seeing, which is, I would say, one of the biggest pain points right now with large scale production, that is scrap rate. In many of our engagements with our customers, various companies we have talked to, we are finding that in the first year of this large scale production, many of the companies are struggling with having a scrap rate as high as 70% or more, which is too high a scrap rate for commercially viable large scale production. Other thing, in addition to scrap rate, is availability of material, availability of cheap material. So in the battery chemistry, cobalt is quite a costly component. So companies are looking at how they can go and pivot to the chemistries that are less costly and for which there is a more robust and diversified supply chain. These are some of the challenges, but Marc, I'll be interested to listen what are some of the additional challenges you have seen in engagements with battery ecosystem.
Yeah, there are different ones. So ecosystem means definitely also the integration of machines into the lines. A line is capable to produce these gigawatt hours of production capacity. And the basic fundamental things are machines. And these machines are coming worldwide from different supplier with different equipments in some cases. And that's quite not easy to handle that for the end customers. They have to harmonize it or to interact them. And the wish of the end customer is definitely a kind of plug and play of these machines, so that they are best optimized and ready to use. And this is in some cases different, really possible, but the quality issue will come up then. They have to interact, these machines, to connect them, and have to make them fast acting with a high quality, because this raw material is quite cost expensive, like Puneet mentioned. And if they have a high scrap rate, they have to improve, and they have to improve the machine throughput. They have to improve the operation of the machine itself. They have even to make the operation easy for the operators, because even this is a quite issue in the market. It's a really fast ramping up business, but the resources, even the human resources, are not yet available. So they have to be educated. Operation mode should be easy to use, easy to activate. Another thing is to make this production also stable against some environmental humidity, temperature on the line. This has to be analyzed and have to be used in a safe mode to avoid that this will have impact on the quality of the battery cell. Then the capacity. So if you build up these huge demands of production sites, you need machines. But not yet all over the world are so many machine builders available who can really offer that amount of machines. The development of these machines have to be fastened up. And this is an idea what we also try to support with, to build that already in a virtual environment and to validate everything, or even in the production later on, to start optimizing these machines that they are reaching a higher throughput. Then tracing also all that material that's usable. So how much material do I have used for which amount of battery cells, and what kind of material? And what parameters did I set up, for example, to have an optimized machine or optimized line output? This is something. Another challenge, which is really, really important if you are working worldwide. So there are a lot of huge companies who have their fundamental base in Asia, but they are working also in Europe as well as right now in the US. They have to build up production lines in different regions, in different areas. And therefore they have to interact in a global team. The execution of the project to build up these gigafactories have to be aligned, and they need resources in these countries as well as systems and methods to make it happen, to have a faster start of production and decreasing the scrap rate. Then the scaling from an idea of a battery. So in a labor environment, it's maybe sometimes easy to develop a recipe, but to scale it up to pilot, or then from pilot line to a mass production, that's a different challenge. The customer needs support also from outside, from machine builders, from suppliers. And how would be maybe to expand their OT, IT solutions, whatever. For example, have a transparency of their production line and figure out anomalies within these production lines to have a better outcome. So these are just a part of all these challenges. There are much more around, and if you participate once in the project, you will see there are so many things that are not visible, but you feel that there's something to do.
I fully agree with Marc and some of the great points he has raised. I just want to add a little bit more color. Marc mentioned about increasing the production throughput, line of speed, and a lot of the variables that come into it. One of the things that we also see, one of the key challenges, sometimes, especially for large-scale manufacturing, there is a bound capital in some of the key manufacturing steps for cell. That means some of these steps of cell manufacturing take a lot longer than rest of the steps, and that starts causing a lot of the specific bottlenecks in the overall production. So how you go and overcome those bottlenecks in the production, such as the time that it takes for cell formation or aging, as an example. These are some of the challenges that every company, be it a new entrant or a incumbent large enterprise who has been making these cells at large scale for many, many years. All of them are struggling with these issues.
So maybe at a high level, how are we helping them address these problems right now?
Definitely, we as Siemens, as a supplier, we want to integrate all the hardware and software and also the whole services around. When we talk about an ecosystem, it starts already also with the planning of this production. That means I have an idea how much capacity do I want to produce, but how to develop that. This can be already done in a virtual environment. You can measure the throughput, you can measure the energy efficiency, you can also calculate how much machines do we need in this case. Then the next step would be how to develop these machines in combination with the machine builder, then how to integrate them, how to standardize, because standardization is definitely the enabler for the digitalization solutions. And that's something what we definitely offer in this market as a global player. And we have on the simulation phase a lot of different accesses and ideas. It starts from a process idea. It means how can I, for example, mix all these raw materials and how can I add this slurry that can be reused further to the coating machines? How can I then have an optimized coating process, reduce the tolerances? Because as we know, chemical reactions are always not under control as soon as the tolerances are too high. We try to reduce the tolerances in this whole processes. Then the logistic inside all these different process steps to optimize the logistic flow, to have a higher throughput as we mentioned. And also at the end, maybe use the data that are directly coming out of the anomalies with artificial intelligence to reduce, for example, the formation time. So which will have much more benefit for the end customers, but you have also to integrate the machine builders and convince them that this approach is easy to use and makes sense to integrate. Yeah, another challenge is green energy. And this is definitely something that has to be considered already at the planning of this production. So what is really clean in a battery production? Definitely, energy use is a really major topic. So when you want to be sustainable, you have to reduce the energy use. Then you have to reduce the use of raw materials. So, or being more efficient. That is something that comes to sustainability. Puneet, do you have something to add on that?
Yeah, great points you made, Marc. I'll just elevate it at a level, adding all the things that you mentioned is when we look at the ecosystem, when we look at the cell suppliers, one thing that is getting clear and we are hearing more and more of is the traditional methods of manufacturing, traditional ways of engineering batteries are not necessarily working to meet the ambitions the battery industry holds. That is, battery industry is looking to do 10x increase in its production capacity. That's not going to happen if they continue using the traditional manufacturing practices. More and more we are realizing companies are looking for digitalization help. How digital solutions, digital twin of production can help companies plan better, how they can validate their process before coming on the factory floor, before implementing them on factory floor, and how they can connect this digital world with the real world. That's what a lot of companies are looking for. That's where Siemens comes into play. Our focus is being a technology partner to battery suppliers, to machine builders in their pursuit to address these challenges. In fact, 8 out of top 10 battery suppliers in the world are leveraging our digital solutions to address such pain points.
Yeah, and not only Puneet align to some other tasks, also via some project phases. So a project is just successful as soon as the start of production is done smoothly and without any kind of problems. So, and if you see a real project of an end customer, you have at least 9 phases, and the idea is from us to be aligned with this end customer as well as the machine builder or also other integrators from the start of the idea until the start of the production, even further on the maintenance level, the service level afterwards when the production is in operation. And therefore, the idea is supporting these customers. And if it comes, for example, to startups, in some cases is quite difficult for them. They have so many challenges to erase. We try to consult them already at the beginning and try to find a really safe way, because they have invested a lot of money, to save this money as well, the investment, to be aligned via the whole project phases. Means the design, the installation, the commissioning in the virtual environment, in the real environment, ramping up and start the production in safe mode. This is what we want to do with these customers.
So I know there's a lot to cover, and I know you guys want to keep this discussion going, but what are some of the upcoming topics and expert guests that you want our listeners to know about and make sure to subscribe for?
So Nick, our ambition is to have a dialogue with battery industry, with some of Siemens' voice, bringing some of our customers, bringing some of the thought leaders in the industry to opine on various topics, such as, is a battery production really clean? Battery production consumes a lot of energy. Many times 30 to 40 units of energy needs to be consumed to create 1 unit of battery energy. So how can companies make this very heavy energy intensive process sustainable, green and clean? Other topics such as, how can companies reduce the recall risk with their new battery technologies? I mentioned earlier in the conversation about various efforts that are happening and increasing on developing next generation cell chemistries. We want to talk about that. What will it take to accelerate that development? What are some of the pitfalls that the chemistries that are developed in the labs many times don't make it to the commercialization? So those are some of the topics we want to cover. Marc, anything more you want to add from your side?
Yeah, I have mentioned it already a little bit, but a factory without machines is not a factory, right? So that means we support the machine builders as well. And first, the development, so from process idea to a running machine, as well as the material suppliers. When we talked about the end-to-end, it starts already how to get these raw materials. So that means we have that upstream or component production. And even there, we find ways to get these raw materials and to protect the environment. This is also important, because when we talk about sustainability, there are a lot of generations coming after us, and we have to keep this planet safe for them as well. So that means not using the raw materials. We want to use it in a clean way and in a sustainable way, that upcoming generation can use it also for future purposes.
Those sound like great topics, but if you're a listener and you want to learn a little bit more about how Siemens is addressing the Gigafactory challenges before then, we'll be at Hannover Messe this year, 2023, showcasing our end-to-end battery story. Our experts will also be attending CIBF as well as Battery Show Europe in May. And come September and October, we'll be in North America and India to show off what we have to offer. If you can't make these events or want the information a little faster, be sure to check out our website, siemens.com/battery, and you can find the link in the description. Thank you, and we hope to see you back soon to continue exploring the many facets of the battery industry.